All right. Hello, everyone. It's 7:05, so let's begin. All right. So my name is Ian Arishalmi. I'm representing Alpha Chi Sigma from UVA, and welcome to the Careers in Chemistry workshop. We're so excited to have you all here. So does everyone want to take turns introducing themselves?
I can go ahead and start. Hi, my name is Ashley Tubbs. I'm a fourth year PhD candidate at Virginia Commonwealth University, and I'm the chair of the Virginia ACS Younger Chemists Committee this year. Great to meet everyone.
Hi everyone, I'm Carissa Hunter. I'm a fourth year PhD student at George Mason University in Fairfax, Virginia, and I assist Ashley with the Virginia YCC.
Is it our turns now?
Yeah, sure. Do you want to just quickly introduce yourselves to the audience? Yeah.
My name is Andrew, and I recently graduated from George Mason with my PhD in chemistry. And now I work for a company called Lambda Consulting and consult for NASA.
Hi, I'm Kathryn. I graduated from George Mason University with my PhD, and I work for a company called Exponent. It's nice to be here.
Hi, I'm Em. I'm a second year PhD student at George Mason right now, so I'm still in the process of the PhD. So that's what I do: research, classing, teaching.
And hi everybody, I'm Devin. I didn't go to UVA or George Mason. I'm from Maryland though, so that kind of counts. But I'm a senior scientist at Merck.
Great. Thanks, everyone. So what we're going to do is that each of the speakers is going to quickly introduce themselves, present a few slides on their histories, their biographies, whatever, and then we'll just open it up to discussion. We'll have a panel discussion, and then we can open it up to the audience. All right. So Andrew, do you want to start us off? Do you have your slides?
Sure, I sure do.
All right. Thank you.
It's just one slide, and I probably won't need the full 5 to 7 minutes. So here we go. Okay, so my name is Andrew Evangelista. I started my undergrad, I started my chemistry career in high school when I wanted to know why water and oil didn't mix, and chemistry was able to explain that, and I really, really appreciated that. So I decided I was going to do chemistry in college, and I went to James Madison as my undergrad, and I very quickly joined an organic synthesis research group. My first semester of sophomore year, I joined that group, and I made this monster of a molecule down here. It has a name, but we just called it molecule 6 because it was the end of a six-step synthesis. And then what we would do is have these attached to titanium dioxide quantum dots and hit it with a couple of femtosecond IRs, a pump probes IR system, and measure the electron transfer from this pyrroline group up here down through this adamantane, through the esters onto the quantum dot. And we can measure exactly how fast the electron was transferring from the top of the molecule to the quantum dot. And while my research was technically in the organic synthesis portion of that, that's where all of the questions, people always ask me questions about the synthetic methods, but it was just like so uninteresting to me. What I was really fascinated with was the measurement, was measuring the speed of the electron transfer. So that led me to decide to go to graduate school to further my education in physical chemistry. And so I went to George Mason, and I originally joined because there was a professor there who was doing astrochemistry. And that was fascinating to me, that we could do chemistry or measure chemistry of space, of stars, of planets, whatever. And I showed up, and my first week of classes, I took his class my first semester. And after the first class with him, I went up to him and I said, Dr. Cooper, I'm a brand new grad student. I want to join your lab. And he said, I'm not taking any more grad students. And I was like, well, that kind of sucks. So then I spent 2-ish years kind of just not really doing any research, just taking all the classes I could. when Dr. Jing finally joined Mason, and he did physical chemistry. And so I joined his research lab. Dr. Witherspoon emailed him as soon as he accepted the position. Dr. Witherspoon emailed him and said, "This is Andrew. He's going to be your first grad student." And back. And I was. I joined his lab, and there I learned how to do nanomaterials. And that kind of took over my research interests. Like once I started learning about what they do and what they could do and how they can be manipulated, and how they could manipulate, it became fascinating to me. And so this is just a very small portion of my thesis. These are upconversion nanoparticles on the left here, all in a hexagonal formation. And then this is an incredibly zoomed in picture, all taken on electron microscopes of those nanoparticles. Where here you can see the lattice fringes of this particle, which is the rows of the alignments of atoms, which is very cool. And down here, this is an optical image of my colloidal nanoparticle solutions with increasing concentration of particles. And what they did was they took infrared light and upconverted it into optical light, into visible light, which is something that is unnatural. So that was what my entire dissertation was about. It was a lot of fun. I had a great time. Most of it was fun. I had a great time doing it. And now I work for this company called Lambda Consulting. And our main client is with NASA. And I got this job because after I graduated, I applied to every possible position I was even tangentially qualified to do, hoping that something would stick. And Lambda Consulting reached out and said, "This job requires knowledge of all of these things. Do you know all of that?" And I said, "No, but I can learn it pretty quickly." And they said, "All right." And then I had approximately 6 weeks of training, and that was it. We consult with NASA on their optical systems. So any satellite or a telescope that they use, obviously light has to go in and follows a path and bounces around and everything like that. And so we consult on that, on the light pathing, on the filtering, on the aliasing of the beam, converging, deconverging, diverging, etc. And then every now and then they'll say, "Hey, we have this question." And we'll say, "Well, this is probably the answer, but you're going to need this part to do it." And they'll go, "Well, we don't have that part." And that's where Advanced Nanophotonics comes in, which is our sub company that makes parts. So we have Lambda Consulting that just advises, and then we have Advanced Nanophotonics that can make the parts that NASA sometimes needs, including this material that, if anybody knows what Vantablack is, it's an incredibly dark material, absorbs 99% of light or whatever. We have this proprietary material, which is why I don't have any pictures for my job option, because all of the cool images are either proprietary or copywritten, so I couldn't use any of them. But we know how to make this material that is darker than Vantablack. It's actually the darkest material known to man, but it's NASA's property, so I can't share it. But for example, if you're looking at a star and you want to know if that star has exoplanets, you have to look at the corona of the star, the coronagraph. If you just look at it through a telescope, the light from the star is going to blow out your systems. You need to filter the light from the star out. That's where this dark material will come in. So that dark material can absorb most of the light from the star while leaving the reflected light from the planets around it. And that's what I do. Most of my day is meetings and people asking a question and me going, "Yes," and then I'm remuting myself over and over and over again. But it's enjoyable. It is related to what I did in graduate school, which is nice. And I got to learn a bunch of new materials things that I didn't know before, like much more of the physics side of it. So it was dually beneficial.
All right, thank you, Andrew. I was always fascinated by astronomy, and it's nice to see how it connects with chemistry. So thank you very much.
Yeah, of course.
Yeah. Kathryn, do you want to start?
Okay, So hi everyone, I'm Kathryn Holguin. I am a PhD student, or sorry, wow, I have my PhD, goodness. It's been a full year actually since I graduated and defended. Kind of realized that today. I'm a battery scientist and consultant for a company called Exponent. And most of my work surrounds looking at batteries, and that's everything from what's in your smartphones, in like watches, to bigger stuff like electric vehicles, and then working with the DoD on different weapons systems that involve batteries and testing. So that's the parts of my job that were the batteries, and then the consulting part, like Andrew was saying, is a lot of meetings and looking forward to collaborating with the Army mostly. As an undergrad, I actually used to work on a weapon system for the Army, and that was one of the big factors, in addition to my organic and materials chemistry degree, that landed me the job for Exponent, was my experience with the Army and the weapons technology that they already have and they needed further consulting with. For my research, I focused mainly on, our tagline was sustainable batteries for the sustainable world. And I have one of my former lab mates on here, Moti. I haven't seen her in a bit, and so that was very exciting to see her join. But that was our tagline, and then we use that for everything. And so my emphasis specifically was looking at sodium and potassium ion batteries, kind of as a way to move away from lithium ion batteries, because of the toxicity involved with cobalt and the expense of the lithium metal. And so what we would do in our lab is we would synthesize our own materials, trying to figure out the easiest and most facile ways to synthesize a material, and then turning them into actual batteries. And so as you can kind of see here, we would start with some kind of ground material that we made, mix it with carbon black, create a slurry, put it on either copper or aluminum foil, punch out little tiny electrodes. And this is like your powerhouse of your battery. If you've never seen one before, assemble everything in a glove box, and then get these really cute little coin cell batteries that we would then test. And through most of our work, we were able to get materials that actually worked very, very well. Myself and Moti included, and some of our other lab mates have had great success in different materials. Myself with sodium and potassium and some magnesium batteries, Moti with magnesium, aluminum, sodium, and potassium. And we would get these awesome little graphs that are here on the side to be able to look at the performance of these cells, the actual raw material. And as part of my dissertation, I was able to use this material both in sodium and potassium and light up these little LED lights to demonstrate practical applications. Not just that it was a easy method to actually go through and make, but it was a material that could actually be used in the world. And so that's what I did, and that's part of how I got my job, and that's what I do. Thank you.
All right, thanks, Kathryn. All right, next up we have Devin. Devin, do you want to get us started?
Yeah. Okay. So here is a general overview of who I am as a person. Like I said, I didn't go to UVA or George Mason, but I did my bachelor's at University of Pittsburgh. I got that in 2016. I'm only 2 years in, almost 2 years into my new job at Merck, but at Pitt, I looked at polymers. I didn't necessarily know that I wanted to go to grad school. I had really good mentors that were like, you should go to grad school. I wanted to be a forensic chemist, actually. And they were the ones that were like, well, you could do analytical chemistry and still, do what you want. And that's what ended up happening. I worked for Tara Meyer, and part of what half of her group was synthesizing polylactic and glycolic acid polymers. And the other half, the half that I was on, was pretty much trying to figure out what the heck can we do with these polymers. So they have plenty of applications and materials, but also in drug delivery. So that was kind of like my first taste into oh, we can use materials for drug delivery applications. So I went to Ohio State. I graduated in 2021. I'm a mass spectrometrist by training at OSU. I actually joined a pre-tenure professor's lab. So I'm happy to answer questions about that for folks that are considering that or are in that and have some questions about navigating that kind of space. But I think I was PhD 5 out of his group. So I was pretty early, pretty new. He was pretty new at Ohio State, but what we really did there along this line of using materials to do chemistry that's relevant biologically. I developed an ionization source that I have a patent for, that I also won a pretty big award at OSU for my last year of graduate school, because I'm Next Generation Innovator of the Year in 2020, which was pretty cool. So I developed an ionization source for mass spec that was not only able to sample biological fluid samples, but also to detect it all from the same substrate. And I did it with a spool of thread. So I really enjoyed being able to be creative with science and this idea that you can use really common things to do really complex and high impact chemistry. Like I mentioned, I wanted to do forensics, and then that quickly changed. As soon as my advisor at Ohio State was like, okay, you're doing fatty acid analysis, figure out what the heck you want to use it for. And the first thing I decided to do, or the first thing I thought about, was could we use fatty acid concentration in blood-derived samples to serve as biomarkers for various things. So I started a project doing just that. I'm focusing on obesity, since obesity is related to plenty of other diseases like heart disease and diabetes, and got to start a collaboration in that lab my last year at OSU with Nationwide Children's Hospital, developing a Band-Aid that was based on the technology that I had built that was going to be used for cystic fibrosis biomarker detection. So part of the work that I did with fatty acids went on, I think their group now is doing diabetes research. And then we have folks in that lab currently working with Nationwide to have a diagnostic tool for cystic fibrosis. So yeah, when I got to Ohio State and that was the thing that I decided I wanted to do, I was like, okay, pharma made sense. And I've always been at big schools, so why not shoot for the stars and work for a big company? I was like, Merck was the goal. And I ended up at Merck. That's where I am now. I've been there since June 2021, and I am in drug products, small molecule AR&D, and I support small molecule oral products. So when you think about typical medicine that you take, you typically are taking a tablet or a capsule. So that's what my department looks at. I am on the drug product side, which means I really care about the active ingredient in a context of a tablet, a capsule, things you can take orally. And what that means is my key stakeholders are formulation sciences. They're the people that are actually making these tablets and capsules. And I have to make sure that it does what we think it's going to do. Is it releasing in the body where we want it to release? Is it stable? I'm also in charge of putting all the documents together for the FDA, which is something that I had zero experience with before I got to Merck. But it's been pretty cool experience getting to work on different parts of Merck's portfolio. Currently, I've historically been working on neuroscience programs and infectious disease portfolio, which has been really, really cool. And these are some other things about me. You're probably going to see a bushy tail walking around behind me. That's my dog, Baxter. But outside of science, I do lots of DEI work. I currently sit on the board for Nobuche, which is a nonprofit that caters to Black chemists and chemical engineers. And I funnel a lot of my DEI work through the stuff I can do at Merck. So I'm really big on recruitment and also trying to make Merck a safe place for students that look like me and from other marginalized backgrounds. So yeah, that's pretty much it.
All right, thank you very much, Devin. I'm pre-med myself, so it's very interesting to see this zoomed in look to how drugs are actually developed. So thank you for sharing. All right, last up we have M. Do you want to share?
Yeah, I will pull it up. Okay, so I figured I'd start with just some background, fun stuff about me before I tell you all about my sciencey stuff. So I was born in Germany. I moved here when I was 4. I grew up in Massachusetts. I did my undergrad in New Hampshire, and then my first big move that I can remember was when I came down here for Virginia for grad school. I love plants. Some of my friends told me last week that the first thing they ever learned about me was that I love plants. So apparently I express it a lot. So love plants. I love dancing, reading, traveling, hanging out with my friends. I'm a normal person. I feel like sometimes we all talk about all of our science stuff, but we're people too. So do normal things too. I've always had a passion for science, but my path hasn't been linear. You know, there's twists and turns everywhere you go, and everyone has things they have to go through. Most days right now, you can find me teaching, taking classes, or at a cafe where I do my computational research because that's more fun than sitting in my lab to do it. So that's a little background about me. My undergrad, I got a BS in chemistry in 2021. I did that at St. Anselm College, which is in New Hampshire. It's a super tiny liberal arts school. I did research there. It was on the quantification of heavy metals in plants. I actually also started undergrad wanting to be a forensic scientist, and they also were like, hey, you should just do analytical work because then you can do more things. So that's kind of why they pushed me to this research group, and I absolutely fell in love with doing research on plants. So then when I was looking at grad schools, I decided that that's something I wanted to do. So when I came to George Mason, I looked at Van Aken's lab group. He also works on plants in a little bit more of a biochemistry way. So right now I look at understanding the relationship between environmental toxins and their response to the toxins in plants. So that right now for me means I'm computationally looking at the upregulation or downregulation of genes in a specific plant when they're exposed to different toxins or things in the environment that can bother them. I'm also really big on mentoring. So I currently have 2 mentors through New Hampshire IMBRI, which is a program that I was a part of when I was in undergrad that just has like older students that were part of the program before that mentor younger students in the program. So that's what I do. I really love it. So I'm actually doing an internship with ACS this summer to work on mentoring as well. So I'm working in their mentoring department this summer to do more focus on that. I really want to build that out. So that being said too, I also put a little QR code on the corner of my PowerPoint that just has my email. If you ever have a question or anything, you don't want to ask it here, you can always feel free to email me. I'm happy to help if I can. So that's it. That's me.
All right, thank you very much, Em. So those are our 4 speakers. And as you can see, chemistry is such a diverse field. It can range from plants to batteries to astronomy to medicine. It's such a diverse field. So thank you all for sharing. And Carissa, do you want to get us started with our first round of questions?
Yeah, sure. Okay, so anyone can answer this, or you all can answer. What's something about your current career that you wish you could change? That's a good one. It came from the registration. If there's anything you want to change or not.
I wish there was another employee at my company that I could make do all the physical work that I don't want to do. Right now, it's just me. So if anything needs to be done, I have to be the one to do it. And sometimes, I really just don't want to get out of bed in the morning.
I gotcha. Anyone else? Okay.
I can give the answer first. I almost think sometimes it was interesting when I onboarded. When I onboarded at Merck, it was in the middle of the shutdown. So everything was really, really hybrid. So if I could change anything, I would honestly change my first 6 months because it was really hard trying to figure out, 1, where everything was, 2, who everyone was, and who I could kind of ask for help with. A lot of times when you got your entry-level PhD, you kind of sometimes get thrown in just depending on if your projects are really accelerated or anything like that, and there's still a learning curve. So if I had a little more time to get acclimated a little bit in my first 6 months, I think that would be something I would change. But other than that, I really like it.
I gotcha. Thanks. Okay, what advice do you have regarding work-life balance in grad school or in your career?
So I will say that in grad school, especially as you're getting towards the end, it's more and more difficult to kind of separate yourself, um, especially because, as I'm sure all of us know, once you get started on something, it's really kind of difficult to stop what you're doing and kind of turn off once you get home, especially if you have a family, or just anything else that you have to dedicate your time or attention to. Um, as far as work-life balance, I strongly encourage everyone when they're interviewing for places, to do more of a deep dive into companies to really learn what the people are like there. How do they actually do work-life balance? Because they'll have a lot more of an indicator, um, since you're brand new and you're not familiar with anything there. Um, that's going to be my biggest advice. Early on in grad school, it's kind of easy because you're just taking classes usually, or just, getting to know how to do things. And it's a little bit more like, oh, okay, like I'm all done, like gonna go home and, do whatever I'm gonna do. But definitely towards the end, it's much more challenging.
I can add on to that. Something that really helped me in grad school that I still do now, in my career, is I schedule time for myself. I'm super type A, live by my planner and my calendar. And I realized when I was in grad school, especially coming up, like you were saying, like on towards the end, like once you try to get to that finish line, it's like, oh crap, I not only need to finish up experiments, I need to write these last papers, write my thesis, put slides together, I'm interviewing. It's chaos. And I realized that like one of the first things to go was my mental health. Like it was how the ways that I took care of myself. So I scheduled it. I've given a couple of talks and been on a couple of panels about work-life balance, and I have what I call dev days. So I schedule time, like I think in grad school I was doing them like every other month, where I could like find a Saturday that I would just block off. My phone was on do not disturb. I was picking, some kind of self-care activity. I always made a big breakfast, ended it with Chipotle because that's my favorite. But I always was really intentional about doing that. Now in a career, I make more money than a grad student, so I can do things a little more frequently. But it's still the same. Like I found the things that brought me joy, and I found ways to integrate that into my schedule and into my routine. So it now doesn't feel like I'm creating time for it because I've already made that space. That would be my advice.
That's a fantastic way to tackle that. I'm also type A, and I live by my planner. Like just if it's not in the planner, it's not happening.
Yep, absolutely.
Just
All right, thanks everyone. So a lot of our audience is undergrads who are still thinking about their postgraduate plans. So what was the process for you, like deciding to move on to a PhD? Did you always know that you wanted to do that, or was it something that you figured out later on?
So for my undergrad, like I said, I used to do weapons testing. And my company offered to pay for my graduate degree if I went. And I said, okay, I'm not doing anything else. I guess I'll go to grad school. But that's not always the case. And so that just so happened to be how it worked out for me, is that I had a company pay for my degree.
I can go. I have known since I was a little kid that I loved school. So I kind of just always thought eventually PhD will happen. I started undergrad thinking forensics, didn't know if that meant I should get a PhD or not. So I wasn't sure, but I was open to like whatever was going to happen. My sophomore year, I switched to being a chemistry major. And then everyone at that point was like, okay, if you're a chem major, like you gotta go get more school after that. And I was like, oh, okay, like sounds good. So then I got thrown into research, wound up loving it. And they were like, okay, well, if you really like research, you're definitely going to want your PhD. And I was like, okay, sounds good. Like, I'm into learning, like, I'll do it. It's fine. So I started applying my senior year. I applied to a lot of grad schools, like 11 or 12. It was a lot, just because I didn't have a great support system in like helping me make a decision or knowing what to even look for. And really all I knew is I wanted to move to the Virginia area. That's like my only thought that I had was I want to be doing research and I want to be near DC. And so I picked a bunch of schools around here, applied to all of them. I visited a bunch. I was lucky enough, I had a lot of options, like a lot of places accepted me. And so I came down here and I looked at a bunch of them. And I actually picked George Washington University. And they didn't accept me into their PhD. They accepted me into their master's program. And they said, we'll probably let you into the PhD if you have some good grades your first semester, like we'll bump you up. And I was like, okay, like the school just seemed beautiful. They had a research advisor that I really liked. And so I was like, I'll do it. And I went there for a semester and I hated it so much. It was just not the right fit for me. The people there weren't great. I did not have a support system, and I already didn't have a great support system from undergrad. So I was really looking for more mentoring and help in the department than I was getting. And so I left after my first semester, and I emailed George Mason because I had gotten in there that semester as well, but I hadn't picked them. And I said, hi, to the head of the department. Could you take me next semester? Is that a thing? Would you mind? And they said, absolutely. And they took me, and I have never been happier since. But that being said, like, even if you make a choice, it doesn't necessarily mean it's going to be the right one right away. And that's okay. And accepting that took a really long time for me. But I'm so much happier now in my new program.
I didn't know I was going to go to grad school when I started my undergrad. And then actually in orientation my freshman year, the freshman advisor, James Madison, sat all of us down, all of the freshman chemistry majors in a room and said, you're all going to go on to a second school after this. And if you want to see patients, you'll go to medical school. And if you don't want to see patients, you'll go to graduate school. And I said, okay. And then junior year, all of my friends were, starting to take their MCATs, or I think one of them went to dental school. I don't know. And I was like, oh, I guess it's time to do graduate school stuff. And that's how it happened. It was never planned. I wasn't born saying, I'm going to go be a doctor. It just kind of happened as life went on. So sometimes there doesn't have to be a plan. It's just you let life happen to you.
Says, what are the best ways to prepare for grad school in chemistry if you're going to take a gap year?
If you're gonna take a gap year, was that the last part of that question?
Yeah.
Okay. I think you want to just really be strategic about why you're taking a gap year, right? Like if you're taking a gap year because you want to get your grades up and you're maybe doing like a post-bac program or something like that, then your gap year is kind of mapped out for you already, because you want to focus a little more on the technical piece of whatever it is you are intending on studying in your PhD. You can also use a gap year if you need a mental health break. And that's also super valid. So make sure that during your gap year, you're preparing for grad school by making sure that your mental health is intact and you've developed strategies to maintain that. It's also it could be really cool, or it could be a really beneficial thing to use it to network. Networking 9 times out of 10, grad school, getting to the next part after grad school is all about who you know. So staying, kind of plugged into any affinity group. So like ACS is a fantastic one. If you're from marginalized background, SACNIS, Snowbichet, there are plenty of others that you can also get plugged into, would be really great resources to keep you connected to the community, but also to kind of keep you connected to science.
I actually took a gap year. I took 4 gap years after I graduated. I got my bachelor's in 2012, and I didn't start graduate school until 2016. In fact, it was so long that my old GRE scores had expired, and I had to retake them again, just because. I mean, I got into grad schools the first time, and I just didn't go. And then I had to take the GREs again to submit those scores to my new applications. It's much easier the second time after you've already done it once and you know what's expected. It's way easier. Anyway, the hardest thing for me was getting back into an academic mindset. After 4 years of working in industry and just like receiving a prompt and producing a product, more or less, being tested again and graded and watched was familiar, but a kind of a shock. You kind of get used to not having to be that scrutinized. Obviously, if you have a boss or something, they're going to be watching you, but it's a different kind of situation. And then having to go back and take a test again. My first test, it was one of Honeychuck's tests. I bombed. I did terrible. It was organic structural spectroscopy, and it was almost all infrared IR data, and I got like a 26 or something, which sounds terrible, but the average was like a 46, so it wasn't that bad. But like absolutely terrible, because I just wasn't used. I had forgotten what it was like to be a student. And so if you're going to do that, I mean, 1 year probably isn't that bad. I'm sure you'll still be able to keep intact, but keep that in mind, that you're going to have kind of like a relaxation, and then you'll have to go back up again afterwards. And then the second test I did fine, for the record, because I found a study group of friends, and I wound up getting an A in that class.
So I will say that I didn't take a gap year between like undergrad and grad school. I did, however, take a break during grad school. So when I first started grad school, I was with a PI who had one foot out the door and wasn't exactly invested in any of his grad students. So much so that he left and didn't really tell any of his grad students. And kind of piggybacking off of what Devin said earlier about your mental health and like scheduling mental health breaks, I had gotten to a breaking point, and I went to our chair, Dr. Witherspoon, and I just sat down and I said, I'm done. If I never see you again, like I did not care. And I thought he was going to be so upset with me. And he just gave me the biggest smile. And he's like, I've been waiting for you to say that you're going to take a break. And honestly, that break I took 3 years, I think. I took 3 years, and I left, and I did nothing. I went on vacation. I just took care of myself. And I actually came back, and that's how I joined up with this group with the batteries and the electrochemistry and material science and everything. And it was a completely different situation. Dr. Lebeau, the sustainable batteries group that I joined, actually was perfect. I had taken all my classes, I had passed everything, I had done all my qualifiers previously. And so I kind of had just a clean break from the department, from everything. And coming back, I was nervous, but thankfully I didn't have, like Andrew was mentioning, like I didn't have to take tests again. And so that was kind of a refresher. But it was very different transitioning from a PI that made it very obvious that he was not interested in helping me grow or learn or anything like that, to somebody who I could go and ask questions to and would have an engaging conversation with me, rather than kind of dismiss me and just pretend like I wasn't there. And so I was able to grow a lot as a person, as a scientist, with Dr. Luo. And when I joined his lab, it was right before the pandemic shutdown. And so I was the first person in the lab to be able to come back in. And so I got really spoiled in that I had all of his attention for like a solid like 4 or 5 months before anybody else came back into the lab. And so that also really helped to solidify that relationship. But I will say that if you're going to take a break for a reason like that, that's fine. There's literally nothing wrong with taking longer in grad school. Like you're not competing against anybody but yourself if you want to. But taking care of yourself is really, had I not taken that time, I don't know how I would have ended up in grad school. I definitely wouldn't have finished. I would have never come back had I not taken that time.
Okay, most common challenges new PhD scientists face when applying for or looking for or applying for jobs that are not specifically chemistry positions. Can y'all hear me? Is this better? Okay.
I think something, I don't know if I fully understood the question, so I think I'm answering it, but if not, you can let me know. I think something that I was really aware of really quick, because I didn't have a bunch of science experience at first, was I was going into these labs or meeting with people like in undergrad and grad school that were so heavy on the science and less about the like who you are as a person and how you can connect with other people and like have relationships that work and teams that work and such. And maybe I was just unlucky, but I think that's something in general that when I've interviewed, I've stressed a lot, is the skills and the work that I've put into communication and teamwork and leadership and that sort of thing, as like next to my actual hard science skills that can make me like directly good for that job. You need these other things and you might not have them yet. Like they are skills that you have to work through and learn how to use and have. And I think sometimes we forget about those, or our mentors or people don't teach us those. And sometimes it's hard to find like where you can learn those things. So yeah.
They're called soft skills, and they are incredibly hard to acquire if you are not naturally gifted and born with them, which bless those people, because I started with 0 soft skills, and they are certainly a tough acquisition for sure. Technically, my job is not in chemistry. My job is in materials and optics, which is not what my training is. But like I said, I applied for every job that I was even closely related to. And this is the one that landed. And what getting a PhD teaches you isn't necessarily science, chemistry specifically. I mean, yes, it obviously does teach you that, but what it teaches you more importantly is how to learn, and how to learn quickly and fast. And that's what's important. So even if you are not exactly your job is unlikely to be exactly what you did in graduate school. I'll say that there is a very low chance, unless you were going to graduate and start a company with your advisor, which I know people that have done that. it's probably not going to be the same, and that's totally fine. It doesn't matter. Once you have that PhD, you have an invaluable skill set to most employees. And as long as you are close, or sorry, to most employers, and as long as you are close, like they don't want to have to reteach you how to do basic math. As long as you have those baseline skill sets, that is going to be more than sufficient, because whatever knowledge you need on the job, you'll pick up very, very quickly. And that's what a good hiring manager will recognize.
All right, thanks everyone. So we have some more time. So we want to take this opportunity to just open it up to the audience. Feel free to unmute yourselves or write any questions you have in the chat. We'll be happy to answer them.
I'll go quickly. Hi all, I'm Anshu. Confession, I'm a computer science PhD student, but I took many chem classes in undergrad, and I really like being here and I'm hearing about your experiences. And I was actually just writing a message which I just put in the chat. But thank you all for your comments regarding graduate school, regarding advising in graduate school. I just entered PhD candidacy, so this is my 4th semester at William and Mary. It's like finished classes this past fall, and it's interesting. It's I started it PhD candidacy while also entering a full-time job because I wanted to make more money than I could as a research assistant. And also I kind of looked forward to like actually getting some real world software development experience and work experience. For once, I've been in school continuously for my entire life up until I started this job. So except for like, summers and summer research and internships, but yeah, like advising, I often find myself like, wanting more guidance from my advisors. Part of it is just like, time. They're both teaching classes. Part of it is just like, quality of advising. Part of it just is me. Like I feel like in grad school, a lot of professors expected us to come in knowing how to do research. And I'm like, I still need more guidance on how to do research. And sometimes I feel like my advisors expect me to be better at that than I am, expected to be more developed than I am at that. So it's like, it's wondering, it's like, do I need to improve something, or is it do I just need better advising? Is it a mixture of both? Because like, yeah, I'm a student, I got a long ways to go, but job of professors is to help along that route. So just thank you all for your contributions. I'm sorry I didn't have a specific question, but I may think of one and ask later.
All right, Delaney, do you have a question?
Yes, hi. Thank you guys for coming today. I appreciate it. I am a sophomore undergrad at UVA, and I am biochemistry major, but I am looking into forensic science, specifically forensics biology. And I'm entering a research lab over the summer, doing a lot of forensics biology stuff with some graduate students. But what the two people that were forensic science, what made you guys shy away from that? Is it anything I should be aware of, or was it just the way life took you?
So a couple of things on that point. I will never forget the look on my advisor's face. My academic advisor, she was like, you need to just do analytical chemistry because all forensic scientists are analytical chemists anyway. You're gonna get all of the training, and a lot of forensics grad programs, whether masters or if there are any PhDs, they're scarce and they're typically not well funded. That's one of the bigger reasons why I was very quickly like, hey, let's just pivot just a little bit. Analytical, you can essentially do pretty much whatever. Carissa's an analytical chemist. Emma's an analytical chemist. I'm an analytical chemist, and we do 3 completely different things. So analytical teaches you how to think about an application using some type of toolbox, right? And you might get a PhD with the specific toolbox. Like I'm a mass spectrometrist, but I do know and understand how other analytical techniques work. And even if you're doing like what Andrew does, like with materials, that's still, optics is still a form of analytical chemistry, right? So you can still, it's broad enough where it encompasses a lot of types of careers, so you can still do what you want. You just have a more broader background, and if you do get exposed to something else, then you have more options. You're inherently more qualified for more positions, doing something a little more broad, like analytical chemistry.
Yeah, that's the exact same speech that I got when I was switching. Everyone said, forensics, that's great. If that's what you want to do, you do that with your life, but get it in an analytical chemistry way. Because if you have that broader outlook, then if you graduate and oops, it's a really niche field to be in forensics, I can't find a job right away, I can go work in an analytical lab doing anything else, still build those skills. And then when I finally see that job opening that's perfect for what I want to do in forensics, go apply for it. So it's just like, it gives you a broader option list when you're done. It's just a really niche field in school, in jobs, in everything.
I've
So
been looking at grad schools and stuff, and there's like 3 accredited ones on the East Coast or something like that. So I'm like, oh, okay, great.
yeah.
An internship though. So in between me graduating from Pitt and me starting at Ohio State, I did an internship at the DEA. So I got to play with, I couldn't play with the drugs that they had at the DEA. We could play with all of the adulterants, so things that drug dealers cut drugs with. So I got hands-on experience working at the DEA. And that was super valuable. It was great. I had a fun time. You got to kind of talk to folks that are doing this work every day. I just realized I wanted more of a continuous challenge. Like the type of work that I would have done if I went to a place like the DEA limited this type of job that I wanted. So consider an internship. So whether it's at like a coroner's office or like a crime lab, that could also give you that hands-on experience while you have a degree in something a little more broad.
Okay, cool. Thank you guys so much.
All right, are there any other questions from the audience?
Yeah, I have a couple questions. Hi, I'm Jacob. I'm a fourth year PhD student at VCU. I'm actually in Ashley's cohort. So hi, Ashley. My question was the confusing question, I guess, more so looking at interdisciplinary jobs versus just strictly chemistry jobs. So in my lab, we do femtosecond, time resolved mass spec with pump probe spectroscopy. And so a lot of that is the physical chemistry side with how are these, and our research is funded through the Army Research Office. So we're looking at these energetic materials and, on the femtosecond time scale, how do these things fall apart? So that's obviously not a very specific thing that, like, Andrew, you were saying, looking for jobs. So I guess pivoting to a different question, maybe more towards Andrew and Kathryn, looking for jobs that are like government versus not. So like continuing with optics or lasers in different capacities, whether that's like a national lab or whether that's like working through like Exponent, which is a company that works, with the Army, but it's not related to the Army, or working at Lambda Consulting, which is not exactly working at NASA, but, consulting with NASA. How did you guys kind of straddle, like, I guess more towards Kathryn, like you had experience with the Army. Did you look at like Army research, like labs specifically and national labs and because I'm trying to navigate where it's like my skill set is more towards things that aren't chemistry. And I'm like,
Yeah.
maybe I should have gotten a physics PhD.
Don't go physics. Don't do that.
No.
You'll have a harder time with physics.
Yeah.
Yeah.
So like Andrew said a couple times, he and I actually graduated just right after each other. I applied to every single job I possibly could. If it was even kind of remotely, maybe something I was kind of maybe interested in, I applied to it. I specifically did not apply for lab jobs where I would be in the lab all the time. I was a little funned out for being in the lab all the time. As I'm sure a lot of us got to at that end point where it was like, if I have to go into the lab one more day, I'm just gonna scream.
Yeah.
I was all funned out. And I had, like I said before, I had experience doing weapons testing and Army consulting before, and I really missed doing that. I miss the interaction of using my knowledge and being in meetings and working on from that side of things rather than from being in the lab. And so I really just applied everywhere. And as far as like getting jobs and getting interviews, that wasn't the issue. The issue was moving forward in the process. Like we would get so far and then it would kind of be like, oh, okay, well, we're going to go in another direction. Or for a lot of government jobs, like the EPA or DOD, it's a lot of funding issues. They don't have funding right now to hire people. And so you're kind of just queued up waiting and waiting and waiting. I actually just got a notice today that said that I was selected for a job. And I was like, oh, that's fantastic. I already have a job now.
Yeah.
So it's a little not helpful at that point.
Okay.
So that's another thing that's going to happen too, is you'll apply for 100 jobs in 3 weeks, and then you'll hear nothing for 6 months. And then as soon as you get a job, all of the other jobs you applied for are then interested in you. It's really annoying sometimes.
Yeah. Considering that, how far out should we be applying for things? I heard someone spin it like for every like $10,000 you want to make in salaries a month out, you should be applying or something. Like,
No,
like I guess like, we're gonna get our doctorates, or at least I'm getting my doctorate in like a year. So like when you're applying for positions that require, you to have a PhD as like an initial, qualifier, do you email people 6-8 months out and say, hey, I'm getting it,
yes.
I will be done with it?
So you can put on your resume, what is it, ABD, all but dissertation,
Yeah.
which means like you've done all of your other qualifications for your doctorate. So you put your expected graduation date and you write ABD. And that tells the people that are looking at your resume that by that time you will have your PhD. And they take that into account. And you said you have a year?
Yeah, I mean, we're about to finish up the 4th year, so I'm basically in that. I'll have just the defense left in, next spring.
It's, what is it now? April? Start in June.
Yep.
Yeah.
Yeah.
I'm going to a conference in June and I'm hoping to network. But
Start then.
yeah.
Definitely.
When I was about to leave my last year of grad school and I was trying to look for jobs, I introduced myself as, hi, my name is Devin. I'm a 5th year PhD candidate and I'm graduating in May. Like everybody knew, every single person I networked with knew I was out and I was on the job market. So go your business cards, go with resumes, be prepared to like, make sure your LinkedIn profile is up to date before you network with people, because all we're going to do is stalk you on LinkedIn,
which
just
is
to start getting an idea of where your skills fit. But 100% by the summer, if you know you're going to be out around spring, start applying. A lot of jobs, unless they say explicitly that they need someone to start ASAP, they do work with entry-level PhDs and hire a year, even I've seen 18 months out, depending on the position.
Yeah. So when introducing and talking to people understand that people are looking for jobs, and it's not like rude to be like, hi, I'm doing this stuff. I'm looking for, Army or Navy, military, DOD type research. It seems like your poster's talking about that. Like, I'm, looking for a job, looking for a postdoc. People are expecting that.
Yeah.
yes.
Yes. If they're looking for PhDs, they will understand what that means.
If they're looking for new PhDs, they will absolutely know.
Okay.
9 out of 10, a lot of companies are really interested in cultivating relationships with students. So we hear like future talent a whole lot. So if you get in on the ground early with people and hit it off, you can have informal interviews with folks just to kind of get a sense of what they do. They might be able to better connect you internally to where you would fit really, really well. But a lot of companies are moving towards, have been in this model of, okay, we identified really talented 4th year students that we are gonna wanna hire in a year, and they build those relationships. So this is the perfect time.
Okay, cool. Thank you guys, appreciate it.
Also, both the Navy and Army research labs have chemistry labs up here by DC.
Okay, yeah, because I mean, Yeah, yeah, because I was looking at national lab postdocs, different places, but all the
NRL hires
labs,
all the time.
laser labs
Mhm.
and stuff are in like Livermore in New Mexico, and that's a no from my girlfriend. So we're trying to make it work.
Good luck.
Thank you.
All right, so I think we're just about ready to wrap up. Are there any just closing thoughts from our speakers before we conclude? Any last pieces of advice for our students?
If you feel overwhelmed, it is, but it does end. I didn't feel overwhelmed until I started writing my dissertation, and then it was like 1,000 weights had landed on me all at the same time. It was like once there was a light, then it became real, and it was a race to the finish. But take your time; it's fine. It does finish.
And the only thing I'll add on to that, and ideally you find a way to enjoy it your last year. Even if, you set little milestones for yourself of like, all right, I finished chapter 2 today, let me go celebrate. Try to find joy in the end of this chapter and in the beginning of a new one. Like, I think it's really important that, yes, it is super overwhelming, and I do not miss writing, but it will also help me get through it with finding ways to be proud of myself and be proud of my accomplishments that I had made throughout that journey.
Yeah, I'll add to that and say, no one is denying that it's difficult. There's a reason that we only did this once. But take time for yourself and be kind of forgiving, because you've made it this far, and your PI, your advisors, your committee members won't let you get this far if they don't have the confidence in you to know that you're going to succeed. So at least there's that, and really kind of rely on your lab mates. If you have really good lab mates, that also really, really helps.
All right, if that's all, I think that's it for this presentation. So thank you, everyone.